Alrighty, welcome back. Just a quick exercise on properties of mean and variance. This is exercise 15D. Um, just a reminder about some things that we've already sort of covered. So again, if you are getting the expected value of a function, it doesn't necessarily mean it's equal to the function of an expected value of x. However, there is an exception, and that exception is where the mean is a linear function of x. In this particular case, where it's a linear function of x, there is an additional process we can use. And it says here, for any continuous random variable x, if you get the expected value of ax plus b, so a linear function, it is equal to a times the expected value of x plus b. Cool. So that's an important one to note. I'd write that down in your notes. Also, same sort of thing can be applied for variance with a linear function of x. So again, if you are getting the variance of excuse me, ax plus b, here you can see it does, the formula says it's just the a value squared multiplied by the variance of x, which is useful. So please make a note of those. Some other things, again, with these linear functions. It says here, we've got the probability density function of ax plus b. If you have this plus b on the end here, essentially what it's doing is it's translating that probability density function. And so essentially, again, you can see here by the translation of what's going on, we're adding onto the x value. So therefore, the rule would be f of x take away b. So that's what effect this plus b has. Again, the a, so multiplying of the x, it's similar to the dilation of a factor of a from the y-axis. So again, we need to, there's a rule for that, and essentially the rule is 1 over a multiplied by f of x over a. So that is important. And then you can get what I call the combination, where you can have both the b and the a value together. And again, in this particular case, you're just applying both of these to that function. So you'd end up having 1 over a f of x take away b divided by a. Cool. So let's see how this actually works in an example. It says here, suppose that x is a continuous random variable with a mean. So here mu is equal to 10, so that's the mean. It's 10, the variance is 2. It says find the expected value of 2x plus 1. Now again, hopefully you realize that's a linear function there, so we can use the rules that we just spoke about. So again, this is the a value, this here is the b value. So the expected value of this is the same as a times the expected value of x, so in this case 2 times expected value of x plus that b value. Running the calculation, we had here the expected value of x, or the mean, or mu, was 10. So it's 2 times 10 plus 1, which we can calculate as being 21. Next one, it says here, find the variance of 1 take away 3x. Again, this here is a linear function, but note it's not in exactly the format that they've suggested above. Don't get tricked that, remember, this here is the b value, and this here in front of the x is the a value, so negative 3. It's the same as finding, the variance of negative 3x plus 1. Okay, they've just obviously written those terms in different spots. So again, we just apply the rule that was that we spoke about up here to calculate the variance. It's just going to be that a value, which in our particular case was negative 3. So negative 3 squared multiplied by the variance of x. Cool, so here we've got negative 3 squared multiplied by the variance of x, and we were told in the question up here that the variance of x was 2. So 9 times 2 is 18. Happy days. This one here, last one, says if x as probability density function of x, function f, describe the rule of the probability density function g for 2x plus 1. So again, we know that this here is the a value, this here is the b value. Essentially, you're going to be plugging it into this here, where the A is and where the B is and so forth. And so in this case, writing it out, it says here the ruler is g of x, as we just discussed, where A was 2 and B was 1. And so we're just plugging these into the different spots, and therefore we get the function g of x is a half f of x take away 1 over 2. Thank you very much for listening. Nice quick one today. Bye for now.